Unit circle, as I said, it has a radius of 1, and it will be easy to determine the trig functions, and I'll explain what that means in today. Okay, any angle that starts with the initial side on the positive side of the x-axis, and let's say it has the terminal side anywhere on the circle, in going counterclockwise, it's considered the positive angle. So this is a positive angle, and also in the standard position. So positive angle. It goes counterclockwise. We like to use Greek letters for measures of angles, so that's alpha. It is in standard position because the initial side is on the x-axis and the terminal side is somewhere on the circle. Initial side, terminal side. This way, positive angles. Of course, I could have an angle that is a negative angle. I'm going to call it measure beta. It is still in standard position because the initial side is on the x-axis and the terminal side is somewhere on the circle, and the terminal side is in a particular quadrant. But it is considered negative because it goes clockwise. So clockwise negative, counterclockwise positive angles. We have two ways of measuring angles, with degrees or radians. So angle measure, degrees, radians. You can say, why do we need two? And the answer is, we don't. But when it comes to certain formulas, we cannot use degrees. We must use radians. So we might as well present them from the very beginning. So an angle can be measured in two ways. It doesn't mean that the angle will have different measures. No. A 30-degree angle will be a 30-degree angle, but it will be converted into radians. It will still mean 30 degrees. Okay. When it comes to degrees, it's easier to understand. Because if I say alpha is 270 degrees, then you will know immediately that, and I will say it's standard, this is a standard angle in standard position. Then you will say, I know this is the initial side, and where is the terminal side? So this is 90, this is 90, and this is 90, right? 3 times 90 is 270. So this is the angle of 270 degrees. Alpha equals 270 degrees. But if I say, well, let's look at an angle, let's say angle beta of 2 pi over 3, and I don't say anything, I don't write anything, then you know that this is in radians. So if I say 2 pi over 3, I mean radians. I don't have to say radians, but this is what I mean. But this is a little bit more difficult to figure out where is the terminal side. The initial side, yes, please.
Can you substitute pi as
Of course. Absolutely. That's what I'm going to do. Excellent. So before I explain what this is, we will have to look at, first of all, what a radian means. What is a radian? Okay, so let's look at a circle. This time the circle has a radius r. It can be 1, it can be 3, it can be 2.5. It's a radius r. If I measure the radius So this is the length of the radius, right? And then I put it on the circle. So I measure this, and this will be equal to r. I stop here because this is r. This angle has a measure of 1 radian. So how do we remember this? So whatever the radius is, when the two radii subtend or have an arc between the two of them of the measure of the radius, this central angle has the measure of 1 radian. So that's what 1 radian is. We're not going to think in these terms, however. What I'm trying to say here is this, that they are in a circle. There are 2 pi radians. If in a circle there are 2 pi radians, it means that 360 degrees, which is the full circle, very good, that must equal 2 pi. And of course I want to make it simple. How will I make this equation simple? By dividing both sides by 2, just to make it simple. So now from now on I have to know that every time I talk about an angle of pi radians, I know I'm talking about 180 degrees. So coming back to our circle, this is 0 degrees or 0 radians, but it's also 2 pi or 360 degrees. This particular point right here, right? So 0 degrees or 360, 0 radians or 2 pi. The terminal side is in the same point. What about here? What do I have here? I know I have 180. What else can I say I have? Pi radians, or just pi. Good. What about here? This must be right in the middle between 0 and 180. So what will that be at the top? Pi over 2, right? It will be 90 degrees, and between 0 and pi will be absolutely pi over 2. So since I know that 90 means pi over 2, then I have 1 pi over 2, 2 of those, and 3 of those. So how many radians do I have here for this angle? 3 pi over 2, right? And also 270 degrees. Now, coming back to this relationship between degrees and radians, I'm going to copy it one more time. So 180 degrees represents pi radians. What about 1 degree? In case I want to change something into radians, what should I do to both sides of this equation to get exactly how much is 1 degree in radians? What should I do to both sides to get 1 on the left-hand side? 180, of course. So I divide both sides by 180. So 1 degree corresponds to pi over 180. What if I want this side now? I want 1 radian on this side. What should I do to both sides to see how much is 1 radian? Correct. So 180 divided by pi. So now let's look at the graphing calculator for a moment, because I would like you to try to remember if possible. So clear if you have. I worked with my other students on this, something else, other class. So 180 divided by pi. Here's your pi right here on the caret, right here. So with the second key and pi, and press enter. And I would like you to remember that 1 radian is approximately how many degrees? A little bit less than 60. How many? 57. So please remember, this is what we divided. So 1 radian is approximately 57 degrees. It's useful to know this. I'm not going to test you on it, but it's useful to know when you check your work for whatever reason. Okay. I like to work on a couple of problems and also talk about coterminal angles. Okay? So let's talk about coterminal angles first. Okay. Two angles are coterminal if they have the same initial side and terminal side. If they have the same initial and terminal sides. Is this extremely important? It is important. Something else after this is more important. But yes, it's useful to know that I can create as many coterminal angles I can possibly think of. So here's the first angle. Let's say it has 30 degrees. So here's my 30-degree angle. It's a positive angle. I will say 30 degrees. Here is a negative angle that will be coterminal with this one. It has to start at the same spot, and it has to end at the same spot. So this is one option. What will be this coterminal angle? First of all, it's a negative angle, negative 330 degrees. If I had gone all the way, it would have been 360, but I have to stop 30 short of 360. So 30 degrees and negative 330 are coterminal angles. Why? They start at the same spot and they end at the same spot. Coterminal angles. Okay. Now here's another example with a positive coterminal angle with another. So let's say this time I'm going to use 150 degrees. 30 short from 180. This is 180. I'm going to stop 30 short this time. So this is the angle, let's say angle alpha, which is 150 degrees. And now I would like to determine one coterminal angle that is positive. And here's what I will do. 360. I want to continue 360, which is 720. 720 plus 150. 720 plus 150 is 870. So the coterminal angle that I wanted to create this time started, of course, at the same spot with alpha, ended at the same spot with alpha. I decided to go around the circle twice. They're still coterminal angles. Coterminal angles. What is more important and is very useful, because I need it for the next sections, is what is called the reference angle. The reference angle. We'll have examples of coterminal and going back and forth in a moment. But I just want to talk about the reference angle that I need. And it's super important, more than coterminal. Okay. Now, here's an angle. Let's say in the third quadrant, with the terminal side in the third quadrant. This is angle alpha. Is it clear that this angle is more than 180 degrees? It has more than 180 degrees, so it's definitely obtuse. Do you think that this angle that has more than 180 degrees can fit in any triangle? No, because the sum of the angles of any triangle is 180. So how can one angle alone fit in any triangle? The question is, how can I find eventually trig functions of this? Because all trig functions, in a minute we'll get to that, all trig functions are defined in a right triangle. So how can I find sine of an angle or cosine of an angle that is more than 180? I can. It exists. Why? Because these functions are periodic functions and they exist for everything. Okay? So how will I determine it? Well, I have to find the reference angle. The reference angle is the acute angle formed between the x-axis and the terminal side of the angle. One more time. This is very important when we get to determine the trig functions of such angles that do not fit in a right triangle or in any triangle. So angle alpha has a reference angle that is formed between the terminal side and the x-axis, and it must be acute. I cannot use this. You can say, wait a minute, so here's the terminal side, here's the x-axis, why don't you use this? It must be an acute angle, which means less than 90. So I cannot use this. This will be the reference angle, RA. Yes, please.
Why can't you use that 270 degree angle?
Very good question. You could. You could use the reference, the y-axis. But it was defined, the reference angle is defined using the x-axis, and it's easier. And I'll show you why it's easier. But yes, you could use the y-axis and consider this the reference angle, but I don't recommend it.
Can you like subtract the amount
Yes.
from that angle?
Yes, you can. Of course, you can. But the reference angle is always determined or considered based on the x-axis. The acute angle formed between the terminal side and the x-axis, but yes, you're right, you can use this angle instead of this, and you will get the same thing. But you have to be more careful for that. Okay, so now that's all we have in section 5.1, but I would like to practice with problems from the book now. Convert each angle in degrees to radians. So, for example, problem 18 on page 529, because I want you to see these things. We are asked to change 330 degrees to radians. And let's say, gee, I don't remember how much is 1 degree, but I definitely remember that 180 degrees equals pi, and from this relationship I can determine how much is 1 degree. I don't have to memorize or remember anything but this. What do I do to both sides to get 1 degree? Divide both sides by 180. So if 1 degree is pi over 180, 330 degrees will be 300 multiplied by pi over 180. I will simplify 0 with 0. I will simplify by 3 and by 3. And I will leave it as is, as 11 pi over 6. I don't have to write the measurement unit. It's understood. Bless you. So 11 pi over 6 means radians. Danielle, you wanted to say something? No? No. Is it okay? So it's 330, but I know that it's 330 times 1 degree, right? When I say x, I mean x times 1. When I say 330, I mean 330 times 1, right? So then 330 times 1 degree which is pi over 180, and I simplify as much as I can, and I get 11 pi over 6. Better? My pleasure. If you don't stop me, I will not know what I'm missing. So please stop me if you have questions. Convert each angle in radians to degrees. Let's say problem 22. It's pi over 9. Here, this is easier, because all I have to do is replace pi by 180. So 180 divided by 9 is how many degrees? 20 degrees. Okay. Problems 41 through 56. Use the circle shown in the rectangular coordinate system to draw each angle in standard position. Standard position means it starts on the positive side of the x-axis. State the quadrant in which angle lies. When an angle measure is given in radians, work the exercise without converting to degrees. Okay, you don't have to do that. So first of all, let's talk about quadrants. What quadrant is this? Good. Can anyone tell us the sign of x and y here? So x is positive, y is positive. This is the second quadrant. What is the sign of x? No, he's right. No, he's right. No. Sign is for x is negative and for y is positive. And this is the third quadrant. Both are negative. Very good. And this is the fourth quadrant. X is positive and y is negative. Keep this in mind. We're going to come back to it. So I'm selecting, let's say, 7 pi over 4. So 44, 7 pi over 4. Three angles we need to remember. Not more than 3, but 3 we need to remember. Pi divided by 6. It's 180 over 6. How much is that? 30 degrees. So every time we talk about pi over 6, now we know it means 30 degrees. The next one is pi divided by 4. 45. We have to remember that pi divided by 4 represents 45 degrees. And the last one that I ask you to remember is pi divided by 3, which is 180 over 3, which is 60 degrees. Every time you get something over 4, like in this example, 7 over 4, can you tell me how many 45 degrees are in here? 2, right? 45 and another 45. 45 and 45 make 90, right? So pi over 4, pi over 4. How many are here? 2. How many are here? How many are total? And I'm asked 7 pi over 4. Which quadrant will that be in? In the fourth one, right? So this is the initial side, and this will be the terminal side. Right in the middle. So this must be 7 pi over 4. So every time we talk about pi over 4, just remember there are 2 pi over 4 in each quadrant. 1, 2, 3, 4, 5, 6, 7. Okay. 51. They're asking us to place 120 degrees. So for this one, the answer is the fourth quadrant, as you mentioned, as you said. Now 120 degrees. I know that this one is 180, and I have to stop short how much? From 180 back to 120. So remember one thing. How many 30-degree angles are in each quadrant? 1, 2, 3. 1, 2, 3. 1, 2, 3. 30, 30, 30 is 90. 30, 30, 30 is 90. So 1, 2, right? So if I want pi over 6 is this. If I want 2 pi over 6, which is pi over 3, is this. But now I want 120, right? So I want 1, 2, 3, 4. So that's where I want to stop. So this is the initial side, this is the terminal side, and this is 120 degrees. Okay, let's find problem 58 on page 529. They're asking us to find a positive angle less than 360 degrees that is coterminal with a given angle. So they don't want us to go around the circle as many times we want. They want this angle to be less than 360. So we have, let's say, 58 caught my eye, 450 degrees, 15 degrees. So they want us to find a positive coterminal angle with 415. Well, first of all, I need to see where 415 is. And I will subtract 360 from it. So when I subtract 360 from 415, what do I get? 55, okay? So then I know that this angle starts, it's a standard angle, it starts on the x-axis. It goes around the circle 360, and then 55 more. I know that this will be 60. So I have to stop a little bit short of that. So this is 415 degrees, this whole angle from here. They want us to use to find a positive angle that is coterminal with this angle, and it's less than 360 degrees. What will you say? 55 degrees. It starts here. It ends here, and this is the angle, coterminal. So these are coterminal angles. Ready to move on? Okay. Right triangle trigonometry. Right triangle trigonometry. Okay. Here's a right triangle. I'm going to call it alpha with an acute angle alpha. I'm going to denote the sides of this triangle by A, B, and C. Tell me which one you want it to be A, B, and C. Doesn't matter to me. The longest is A. Very good. A, B, and C. Perfect. And we will define 6 trigonometric functions of angle alpha. 6 trig functions for angle alpha. Here they are. Sine alpha. Sine alpha, by definition, is the opposite leg over the hypotenuse. So opposite leg over hypotenuse. That is C divided by A. The second trig function is cos alpha, cosine alpha, which by definition is adjacent leg over the hypotenuse, which is B over A. The third function is tan, tangent alpha, which is opposite leg over the adjacent leg. Opposite leg, adjacent leg, which is C divided by B. This is also sine alpha over cosine alpha. The fourth function, COT, cotangent alpha, which is 1 over tangent, which is cosine alpha over sine alpha. So it's the adjacent leg over the opposite leg. Two more. SEC, secant alpha, is 1 over cosine. So please pay attention with secant. If it starts with S, secant, the denominator starts with C. The last function will start with C, and the denominator will start with S. So the last one is CSC alpha. It will be 1 over SIN alpha. S, C, C, S, to remember, easy to remember. So if it's 1 over cosine, then it's A over B. If this one is 1 over sine, then it's A over C. So let's review. Sine alpha, opposite over hypotenuse. Cosine alpha, adjacent over the hypotenuse. Tangent, opposite over the adjacent. Cotangent, adjacent over opposite. Secant, it's 1 over cosine, so it's A over B. Cosecant is 1 over sine, so it's A over C. Okay. Let's go back to the unit circle. I will form a right triangle in the unit circle with an acute angle of 30 degrees. So I divide this in 3. So this is the angle of 30 degrees. Now, using this center angle of 30 degrees, I will draw a vertical line from this point onto the x-axis, and that's how I form a right triangle. Since it's the unit circle, can anyone tell us how much is this? What is this length? From this point to the center. 1, very good. Okay. I'm going to enlarge this triangle. I'm going to remove it from here. It's still there, but I just want to enlarge it. So this is angle alpha. I know that this is 1, and I know that this is 30 degrees. Is there any important information about a triangle that has angles 30, 90, and what is this? What is this? 60, very good. Do I know anything from geometry or from your past experience with math? Is there anything special that happens only in a right triangle? 30, 60, 90. Not 29, 61, 90. No. Exactly 30, 60, 90. Is there anything special that happens there that we know of? Anything that we remember? That's okay. Let me tell you what it is. Only in a 30, 60, 90 degree right triangle, the side that is opposite to the 30 degree angle is half of the hypotenuse. So this side is 1/2 multiplied by the hypotenuse. So then how much is this? If the hypotenuse is 1, this leg is 1/2. Now, once I have two sides, using a certain theorem, I will be able to determine this side. What theorem am I getting to? Yes, so I know one leg is 1/2. I'm looking to find the other leg, and I know the hypotenuse is 1. So can anyone tell us what to write? I'm writing the Pythagorean theorem for this triangle. Say it again. Which is 1 squared equals 1/2 squared. Very good. Squared. Good. I want to find x. So how much is 1/2 squared? 1/4, right? 1/2 times 1/2 is 1/4 plus x squared. I want to subtract 1/4, so I get that x squared equals. Very good. So how do I determine x? We studied this a long time ago in chapter 2. Very good. I take the square root. So x equals plus or minus the square root of 3 divided by 2. Because I'm talking about 30-degree angle, and because I'm talking about the first quadrant, I will say, wait a minute, only x equals the square root of 3/2. Because everything happens in the first quadrant. The 30-degree angle is in the first quadrant. Therefore, x must be positive. So I'm coming back to the unit circle. I don't want to write on the same unit circle, so I'm going to go back. So whenever this is a 30-degree angle, and it's on the unit circle, and I want to determine x, and I want to determine y. How much is x? We just determined it. Square root of 3/2. How much is y for 30-degree angle? 1/2. We already know that. It's half of the hypotenuse. Good. So can anyone give us the coordinates of this point P now?
It's square root of 3/2.
Good. And finally, I'm going to ask you two questions. How much is sine 30 degrees? And how much is cosine 30 degrees? So what do we know about sine? We know that sine is the opposite over the hypotenuse. So how much is sine 30? Opposite over the hypotenuse. So the opposite is 1/2, and the hypotenuse is 1. 1/2 divided by 1 is, bless you, is 1/2. Now I want to determine cosine 30. How do I determine cosine 30? Cosine 30 by definition is the adjacent over, good, so what should I write? Over 1. So it's the square root of 3/2. Any questions? I'm getting a little chart going here. Sine cosine, and I need 3 angles. Pi over 6, pi over 4, pi over 3. These numbers we have to remember. So what do I have to put in the chart already? Which of these 1, 2, 3, 4, 5, 6 cells I can fill in? One, 2, 3, 4, 5, 6. Which cell I have? Right? Say it again. No, I don't have that yet. I only worked on pi over 6. How much is the sine? Sine pi over 6. I will put it in. 1/2. How much is cosine pi over 6? The square root of 3 over 2. I already have these numbers. I just determined that sine 30 is 1/2, and I put it in my chart. I determined that cosine 30 is the square root of 3 over 2, and I put it in my chart. Are you with me? Okay. Now what do you think I'm going to do? Pi over 4 and then pi over 3. Before I do pi over 4, I want to draw your attention back to the same right triangle. If this is 30 degrees, can anyone tell us what is this angle? How much? Good. So since 60 is also pi over 3, can anyone give us the sine of pi over 3? How do I determine sine of this angle? Is the opposite over the hypotenuse. So I can already write that sine 60 degrees is over the square root of 3 over 2 over 1. So the answer is good. Can anyone give us cosine 60 degrees? So cosine of this angle is the adjacent over the hypotenuse. So for the red angle, adjacent over the hypotenuse. So 1/2 over 1, which is 1/2. Now I would like to continue filling in my chart. Which are the cells I have now? So I have here what? And I have here 1/2. Now let me show you how easy this is, I think. Sine 30 degrees or pi over 6 is 1/2. But so is cosine of 60 degrees. Sine 60 degrees is the square root of 3 over 2. But so is cosine 30 degrees, the square root of 3 over 2. Okay? So once I know this, and how do I remember? I remember only pi over 6. If I'm asked to find sine pi over 6, I'll say it's 1/2. If I'm asked to find sine pi over 3, I'll say it's not 1/2. It's the other one. Well, what is the other one? The square root of 3 over 2. So all you really have to remember is sine pi over 6. And of course, the square root of 3 over 2. So if anything has a reference with pi over 6 and sine, it's sine, and I'll say, oh, it's 1/2. But if I'm asked sine pi over 3, I say, it's not 1/2. Because I know pi over 6 is 1/2. So it must be the other number, which is the square root of 3 over 2. Now let's analyze pi over 4.